Hi, Mrs. Greathouse here, working on our nomenclature chapter. This is section 9.2. We're going to talk about naming and writing formulas for ionic compounds. Okay, just like you'd have a recipe for your barbecue or chili cook-off, okay, your ionic compounds have a recipe as well. And when we write the chemical formula, it shows what atoms in what proportion are in this compound. It's our recipe in chemistry language. These masks were made out of gypsum. That's a common name. If we were to go to our stockroom and ask for gypsum, okay, our lab assistant might not know what we're talking about. So we need to know what the binary ionic compound name is for gypsum. Okay, so what's a binary compound anyway? It is a compound that's made out of two elements. Bi is our prefix for two. It can either be an ionic compound or a molecular compound, so made with an ionic bond or a covalent bond. Okay, when we name these, we name it by the cation name is its first name, and its second name is the anion name. So if we're looking at NaCl, it's called sodium chloride. BeCl2 is called beryllium chloride. Okay, remember when we were making these compounds in chapter 7 and we were drawing electron dot structures? And then I said, well, do you see the pattern? And I showed you the crisscross method. That still holds true here. Okay, for example, if we look at beryllium chloride in the crisscross method, and we write our cation first, Be2+, okay, followed by our anion, chloride negative, and we take these superscripts and do a crisscross, and those numbers become the subscripts here. We can write our formula BeCl2. Okay, this is a lot quicker than drawing electron dots, but it still comes up with the same thing. The octet rule is satisfied. We're making a neutral ion. The charge on that compound is 0. Okay, here's some more examples. In SnF2, which is found in toothpaste to protect your teeth, we're going to call that tin 2 fluoride. Okay, how did I know it was tin 2 and not tin 4? I kind of had to dissect my SnF2. Okay, so if I know that I'm working with tin and fluoride, and I have 2 of those fluorides, okay, and they're a -1 each. My charge on my fluorine is a 2 negative. Okay, so therefore, to make this a neutral compound, my tin must be a 2 plus. Therefore, I can surely call it tin 2 fluoride. Okay, if I look at SNS2, which is called tin 2 sulfide, this is used in a lot of our dishes and porcelain sinks. Okay, how do I know it was tin 4 sulfide, not tin 2 sulfide? Again, I have to do a bit of dissecting. Okay, if I take this apart, SnS2, okay, my charge on my sulfur is a -2. I have 2 of those to give me a total of a -4 charge. Again, this has to be a neutral compound. Therefore, the charge on my tin must be 4 plus, and I'm going to write that using the stock method, tin Roman numeral 4 sulfide. Okay, so here are some rules for writing formulas for binary ionic compounds. Write the symbol of the cation and then the addition. Okay, and then you're going to add the subscripts that are needed to balance the charges, remembering that the sum of the charges is equal to 0 so that it's a neutral compound, and we're going to use the lowest whole number ratio. If you end up with 2 subscripts that are 3, we know that's really a 1-to-1 ratio, so you don't need any subscripts there. We're going to find those subscripts again by using the crisscross method. Okay, let's do an example. Cesium sulfide. Alright, so I find cesium, it's in group 1. Okay, so its cation is going to be CS1 plus. Sulfide is in group 6, so its anion is going to be S2 minus. I'm going to use my crisscross method. So the 2 is going to go over there, the 1's going to go over there. So CS2S is my result for writing my compound for cesium sulfide. We can do the same thing with our polyatomic ions. Okay, it's the same idea. We're going to make neutral compound. The sum of the charges must be 0, and we can still use the crisscross method. Okay, here's an example. Calcium nitrate. So we're going to have our calcium ion, Ca2+, and we're going to have our nitrate polyatomic ion, which is going to be NO3 minus. This charge is on the whole nitrate, so we're going to look at that as a group, and you can put parentheses around it if it helps you remember that. Okay, so crisscross. So this 1, understood 1, is going to go over to the calcium. This 2 is going to come over here and be on our whole nitrate group. And you need to use those parentheses to distinguish that. So our answer is Ca parentheses NO3 parentheses 2. That's how we would properly write the compound calcium nitrate. Okay, let's practice a few more. So, the actual chemical compound for gypsum that made up those masks is calcium sulfate. Let's practice that one. Okay, so calcium, what's my ion for calcium? Ca2+. Okay, sulfate. You know that because you've been studying Nick the Clam. Sulfate, think of supper, SO4, 2 minus. Okay, I'm going to do my crisscross here. So this 2 goes over here, this 2 goes over here. Okay, so I come up with Ca2, SO4, 2. Okay, I'm not in my lowest ratios because both of these are divisible by 2. So to properly write this one, it's going to be CaSO4 calcium sulfate. Okay, let's try another one. Magnesium phosphate. Okay, my magnesium ion will be found in group 2. Okay, so it's going to be Mg2+. My phosphate ion, think of the word phoenix, P O4. There's 4 consonants, 3 vowels for a 3 minus. Okay, crisscross here. So my 2 is going to come over here. My 3 is going to come over here. Magnesium phosphate will be written Mg3 parentheses PO4 parentheses 2. Okay, and this last one down here is all written out for us, but I want you to name it. Okay, this is going to be, this polyatomic ion here is acetate, so it's going to be calcium acetate. Okay, that's it for tonight. I'll see you in class, and we'll do lots more practice. Thanks for listening.